Welcome to a slow, beginner-friendly lesson on using booleans, made for absolute beginners. We only practice storing true and false in variables. No comparison operators yet, those have their own video. Before we go further, let us hold what a bool actually is. A bool is a value with only two possibilities, true or false. You get a bool whenever you compare things, like asking is the temperature above 30, or is the user logged in. The answer is always one of those two. In Python we spell them with capital letters, true and false. That capital matters. Today we use bools to make decisions, not just look at them. Two values only. Bool values become useful when we combine them. Python gives us three small words for this. And means both sides must be true. Or means at least one side must be true. Not flips a bool, turning true into false and false into true. These three words, and, or, not, are the heart of everyday logic in code. Once they feel natural, a huge amount of programming opens up to you. We will take them one at a time. And, or, not. Picture a balance with true on one side and false on the other. Most real decisions are like that. Is the door open or closed? Is the answer yes or no? Code is full of these either or moments, and the words and, or, not are how we reason about them. True or false? Let us start with and. The word and asks, are both of these true? Here we have a bool called as weekend, which is true, and a bool called as sunny, which is false. When we write as weekend and as sunny, Python checks both. Only if both are true does the whole thing become true. Because sunny is false here, the result is false. And is strict. It wants every part to agree. And needs both. Now the word or. Or is more forgiving. It asks, is at least one of these true? Here someone has no ticket but they are a VIP. Writing has ticket or is VIP, Python finds that one of the two is true, so the whole result is true. Or only gives false when every part is false. Think of it as the friendly word. As long as one condition holds, or says yes. Or needs one. The third word is not. Not does only one thing. It flips a bool. If something is true, not makes it false. If it is false, not makes it true. Here as raining is true, so not as raining becomes false, meaning we do not go for a walk. Not is useful when it is easier to describe what you do not want. Instead of listing the good cases, you name the bad one and flip it. Not flips it. Let us say the and rule out loud in full, so it sticks. True and true gives true, that is the only way and says yes. True and false gives false. False and true gives false. And false gives false. Notice the pattern. And needs every part to be true. If even one part is false, the answer is false. There is exactly one yes, and three ways to get no. One yes, three no. Think of a fork in the road where you can only pass if two guards both agree. That is what and feels like. Two conditions, both must say yes. When either guard shakes their head, the gate stays shut. Most of programming logic is just this kind of gate, repeated clearly. Two guards, one gate. Now the or rule, said out loud. True or true gives true. True or false also gives true. False or true gives true as well. Only false or false gives false. So or is generous. As long as one part is true, the answer is yes. There is only one no, when everything is false. Compared with and, or flips the rule around. And needs all true, or needs just one true. Generous by design. The not rule is the simplest of the three. Not true gives false. Not false gives true. That is the entire table for not, just two lines, because not works on a single bool rather than combining two. You can also apply not twice, like not awake, which gives you back the original value. That is rarely useful, but it confirms that not is just a flip. Small, predictable, and easy to reason about. Just a flip. Here is where bools get powerful. We already know that comparisons like greater than or equal to make a bool. Now we can combine those bools with and, or, not. A single comparison asks one question, like is the age at least 18? Two comparisons joined by and ask a richer question, is the age at least 18 and do they have an id? That reads almost like English, and it is real, working logic. Join the questions. Let us write that decision in code. We set age to 20 and has id to true. Then we write can vote equals age at least 18 and has id. Python evaluates the comparison first, is 20 at least 18, which is true, then combines it with as id using and. Both are true, so can vote becomes true. Read the line aloud and it almost explains itself. This is how real conditions are built. A real decision. Life is full of choices where you pick one path over another. In code, those moments are built from bools. Every if statement, every menu, every permission check rests on something that is either true or false. Small words, real weight. Pick a path. A common and clean habit is to store the result of a condition in a variable. Writing can vote equals age at least 18 does exactly that. The comparison runs, produces a bool, and that bool is saved under the name can vote. Later in your code you can ask, can this person vote, just by reading the name. Naming a decision makes your program read like sentences. Other people, and your future self, will thank you. Name the answer. Here is a gentle idea called short-circuit evaluation. Python reads your conditions from left to right, and it is smart about stopping early. With and, the moment it finds a false, the whole result must be false, so it stops. With or, the moment it finds a true, the whole result must be true, so it stops. You do not need to think about this often. Just know Python does not waste effort once the answer is already certain. Stop when sure. Let us name real situations built from these words. A login succeeds when the username is correct and the password is correct. A discount applies when the customer is a member or it is their first order. A message sends when the device is connected and not set to offline. Notice how each one is just and, or, not wrapped around plain conditions. Once you see the pattern, you start spotting it everywhere in software. Everywhere in software, here is a login check written out. We have a bool saying the username is valid, and another saying the password is correct. We combine them with and into login OK. Only when both are true does the login succeed. This is the exact shape of real authentication code, simplified to its core. Two questions, joined by one small word, and the answer falls out clearly. Every secure system starts from logic like this. Two questions, one word, two roads, one decision. That is what every if statement feels like to the computer. It stands at a fork, checks something that is either true or false, and walks one path. The bool is the signpost. Your job is to phrase the question clearly, and the words and, or, not help you do that. The signpost, a small naming habit, will save you confusion. When a variable holds a bool, start its name with is or has. Is ready, has id, can vote. The moment you read that name, you know it holds true or false, not a number or text. Good names are a form of documentation that never goes stale. Other people reading your code, and you in 3 months, will know instantly what kind of value lives there. Habits like this matter. Is underscore, has underscore, can underscore. When you combine 3 or more conditions, use parentheses to show what belongs together. Writing age at least 18 and, in parentheses, has it or is VIP, makes your meaning unambiguous. Python can figure out an order on its own, but parentheses tell the reader exactly what you intended. Think of them as punctuation for logic. They cost nothing and they prevent a whole class of subtle, confusing mistakes. Punctuation for logic. Let us hold the whole lesson together. The bool type is either true or false. 3 small words combine bools. And needs every part to be true. Or needs just one part to be true. Not flips a bool to its opposite. And we can store the result of any condition in a clearly named variable. If those 4 sentences feel solid, you already understand more logic than you might think. This is the foundation of every decision in code. 4 solid sentences. The takeaway, in one breath. Bools answer yes or no, and the words and, or, not let you combine those answers into real decisions. Name your decisions with variables, start bool names with is or has, and use parentheses when logic gets crowded. That is the entire toolkit for everyday reasoning in code. In the next lesson we step away from logic for a moment and meet the float type, numbers with a fractional part. The whole toolkit. Where does this lead? You now hold the 3 words that power almost every condition in programming. Practice them by writing small questions in your head. Will I take an umbrella if it is raining or if the forecast is bad? That is real and, or logic. In the next lesson we change direction and meet a new type, the float, which handles numbers that have a fractional part, like prices and measurements. Onward to float. Logic is just small pieces joined together. And, or, not. 3 words, but combined carefully they describe almost any rule you can think of. That is the quiet power of bools. Not loud, not flashy, but underneath every decision your favorite app ever made. Quiet power. Thanks for watching. Next, the float type, what it is.